And today we have a webinar on digital twin for biomass boiler and about the question how to save a fuel, how to increase efficiency. We would overview case studies and practice what we have energy advice reached during past years using digital twin technology. And okay, today what we are going to talk is about a very short introduction about the energy advice, what and how we are solving optimization problems, results and experience, what is the technology inside and digitalization process by itself, what are the steps to reach a goal, and what goals we can reach, and what is the return on investment. So shortly about energy advice, we are a technology company, partly businesses, energy efficiency and technological efficiency auditing studies, and part of a business we are cloud developers. Cloud is called EA-SAS, Energy Advice Software as a Service. We are running also a platform on web where EA-SAS become EA-SAS.net become self-service platform for a digital twin and artificial intelligence, where you could use by yourself, put the data to the cloud and process data and have advanced process control. And we created quite a lot application. One of them is related to ventilation system, another to the district heating, another for the cooling. In general, in EA-SAS platform, we have and drying process and raffination process and glass melting process. So many type of digital twins. And today we will talk about biomass boiler and what the problem we are solving. In fact, biomass boiler operators face some issues to stabilize or maximize biomass boiler efficiency. What does it mean, efficiency? It's a ratio of produced thermal energy divided by consumed fuel, for example, in megawatt hours. And we have always theoretical maximum, what we can achieve, but due to operation issues, due to fluctuation of a load, due to change of a fuel, and many other reasons, efficiency is not stable. And if efficiency is not stable, we lose the money, we burn extra fuel, and then we lose the money. Next question is how to prolong highest efficiency operation and then increase time between maintenance. It's absolutely related to the first, how to stabilize. If you stabilize, we prolong efficiency. And we use digital twin in a SaaS platform to reduce energy expenses. In fact, without investment to the hardware. If we come to the boiler or our partners come to the boiler, first we need to connect to SCADA PLC Flue OPC, for example, collect the data online, do inventory, and tune set points like advanced process control to optimize operation. So in fact, we can achieve some percentage of fuel consumption reduction only and only of tuning set points without hardware investment. So how we are solving? Of course, we collect data from SCADA PLC, OPC, many protocols available. We run digital twin on SaaS boiler, and we use advanced process control we change set points, which are delivered from the cloud to PLC, to OPC, in general to the controller, in order to have good numbers as maximum as is possible in operation. Which system is applicable is, in fact, we have many type of vendors in our portfolio. So we can describe it as vendor independent. We have from minimum 3 megawatt to 20 megawatt existing. If you have higher capacity boiler, I ask you to write in the chat what kind of boilers you operate. Thank you for your response. And maximum 20. If you have more, I would be happy to work with more bigger capacity boilers. We have steam boilers up to 20 megawatt, water boiler up to 20, also from 3. It's region dependent. In our region is more or less range 3 to 20 megawatt boilers. We have experience with CHP. Most of our projects are gray type furnace. If you would have fluidized bed, we would be happy to work with you. Of course, condensing economizer also exists in the portfolio. What results we deliver? First, of course, reduced biomass fuel consumption for the same amount of produced heat due to advanced process control. Inventory of equipment, IT infrastructure inventory, automatization, pit quality inventory. Of course, we increase digitalization maturity. We give quite a lot of knowledge on how and when to do and how to do and what to do. And we have better control on top on existing PLCs, on existing SCADA system. And we monitor efficiency of different components like heat exchangers, fan, pumps, and other components. Of course, many logo about how we work and what is inside. Inside digital twin, first, what is a digital twin? Digital twin is mathematical copy, full mathematical copy. So you can imagine in biomass boiler that we run couple hundreds of equations. Asking my voice. Okay, we run couple hundreds of equations inside the biomass boiler in order to describe combustion process, and all these equations are solved using real-time data which we collect each minute from the boiler PLC SCADA in general from a PLC or OPC. You would ask, what is the difference if you have SCADA system? What is the difference between digital twin and standard control system? First, the traditional control system rely on data which are collected from equipment. However, in general, human is responsible to make some set points, and human is responsible for the adjustment of these set points, or some adjustments are already integrated to the control system. But digital twin together with artificial intelligence algorithms deliver set points to PLC instead of operator, or adjust these set points instead of automation engineer who did previously with set points. And these set points optimized are delivered on time. It's very critical. So advanced process control with digital twin mathematical equation which describe process have more benefits against standard control logic. Energy Advice also produce data collection software. For you, it would be less complication to collect the data to the cloud. We produce data reading software, data collection software, and data write software. We collect data minute range, each minute second range data. So we operate million data points per second, and we have open structure JSON standard. And we have quite a lot protocols inside to collect Modbus, Profibus, Profinet, CBus, and many industrial building management protocols, BACnet, like many other protocols inside. Coming back to EA-SAS Boiler as a system, we of course give you access through web on real-time data. We can control and we can meter biomass calorific value and biomass consumption each 5 minutes. We do estimate each 5 minutes. What is you would ask how we can do this estimate each 5 minutes? Because we have inside a couple hundreds of equations. We use online data and do reverse engineering back. Reverse mathematics back till we calculate what is the water content in the fuel and what is the biomass consumption. So and many other like parameters like surplus air coefficient, like how many air was delivered, what is required air for combustion, and computational fluid dynamic issues like pressures and temperatures distribution in the furnace. Of course, efficiency monitoring in real time. And this is tricky because if you look at efficiency through the point of view of flue gas temperature going outside from chimney, for example, you would see 150 degrees. 150 degrees probably would give you description about what energy is going outside, but don't have a description what is energy going inside, because burning of or combustion of a fuel could be in different path of CO and oxidation with methanation and CO and oxidation. So many paths, which is not so efficient path, like different path would have different efficiencies. So fuel calorific value on one hand, and then how it was burned fuel on another hand could give you absolutely different numbers in megawatt per ton of fuel. So we evaluate many of these components and also from combustion part, and also different part of boiler components like heat exchanging efficiencies, like flue gas path, hydraulic losses coefficient, which indicate how your path is, how to say, reduced or increased hydraulic resistance, etc. And we do estimate each 5 minutes. Of course, set points, historical data, PDF reporting, you can get each define and then receive each morning at 8 o'clock report, hourly, daily, monthly, per monthly data, and each morning to dedicated people. Of course, biofuel mass accounting. It's like so in the indirect methods accounting system. And now we start with quite a lot of case study. You would see pictures here, and these pictures is according to the SCADA system view. We adopt this view according to existing SCADA system, just simplify adding some blue or yellow, what is a calculated value and another value are metered value from the SCADA system. And what was the issue? Why was the decision to buy solution? For our client, it is not clear when make cleaning. We lose efficiency, and it wasn't clear what was the reason, when to start, should we stop the boiler operation and do cleaning, what kind of cleaning, yeah, we install a solution, a SAS boiler. We take a data and calculate, for example, number one, it is hydraulic path resistance. And number two is logarithm temperature difference and kilowatt per Kelvin heat exchange efficiency. And this describe us how efficiency is changing, heat exchanging efficiency, and then what is the hydraulic path condition. And here you can see that boiler was in operation. It's 1 year old data, almost 2 years old data now. With thermal conductivity 1, green, hydraulic losses coefficient 2 is blue, and hydraulic losses coefficient was increasing quite fast. However, heat exchanging was quite good, and we stopped the boilers, but we don't take any action on furnace. So we cleaned water tube sides from a water tube side quite fast in a couple of days, instead of cool down the furnace and then wait and then look inside. And after cleaning, we see numbers that after cleaning the hydraulic coefficient increases, but not fully. Efficiency increased quite much. Another project with digital twin, what is the difference from the SCADA system that can do measurements indirectly. If, for example, in this case, client has the issue to calculate what is the flue gas thermal energy consumption for the heat exchanger. In the scheme, we have gas from the furnace, drop box for the ash collection. We had a fan for the recirculation, temperature adaptation, and outgoing flue gas. We have data from the fan frequency, variable frequency drive, active power, and pressure drop millibar. And temperature sensors meter temperatures, and we calculated digital twin, do estimate on what mass flow tons per hour, what is the power in kilowatt, 400, 4,000 or 4.6 megawatt power, and estimate on the fan efficiency and flue gas distribution inside, and what is the heat exchanger energy consumption from the flue gas side. And no additional flow meter is required, and it's very tricky. We had installed flow meter cubic meters per second here, but the correction of a flow meter flue gas at 200 temperature side, it was a bit tricky and with a metering error. Another example is simplified scheme of flue gas condensing economizer. And here we have flue gas condensing economizer, flue gas input temperature metering from the SCADA, output flue gas temperature. We have input water temperature, outgoing water temperature, output water flow, and economizer ratio, production ratio. I mean, economizer megawatt yield divided by boiler thermal yield. is a ratio. And of course, we monitor kilowatt electricity per megawatt heat consumption. So we monitor also logarithmic temperature difference per boiler. We monitor also flue gas path resistance, hydraulic resistance, and this information delivered a couple of things. One thing is optimization of electricity, kilowatt electricity per megawatt heat, thermal. Another is what is the status of the economizer, because the yield of economizer depends not only on water content in the flue gas, in the fuel, also on the supply water and temperature, also on the efficiency of heat exchanging efficiency. And sometimes you see lower or higher yield of condensing economizer, but you never know why. What is the reason? Okay, it's better know when it's bad. Why? So the numbers of efficiency allow us to understand: is it time for cleaning, or is just water content in the fuel and its efficiency is okay? Flue gas recirculation. Another is to estimate what is the flue gas recirculation, and we had from the flue gas ventilator we have some metered values, for example, frequency of variable frequency drive. We had active power, and from these numbers and ventilator characteristic, we capable to calculate tones, kilowatt, and then pressure difference of flue gas ventilator. And why is pressure difference is important? Because this part is highly dependent on flue gas flow here in this loop, highly dependent on many things. And sometimes you have pressure but you don't have flow. You have sometimes you have lower pressure but you have good flow, and this impact the burning process. And if it's impact to a burning process, we need to adjust flue gas recirculation according to the required, according to the need. So estimation on the flue gas ventilator allows us estimate what's happening on also like hydrodynamic, computational fluid dynamic. What is the pressure distribution inside the furnace? What is the temperature distribution inside the furnace? Flue gas metering. Yes, we do estimate also what on the flue gas temperatures, and here in the furnace we see four temperature sensors, and 3 of them are bad. But our algorithm quite well react to the calculated value and then metered value, quite well react to the changes inside the furnace. Of course, we do estimate on efficiency, and we can extrapolate to how it would decrease and what would happen later. And water content, in which mostly affects all modes inside the boiler. You can see here dynamic. When we reach 40 to 45, it's just indicators, but you can see how it's dynamically changed during the time. And it is 11 day and 12, so it's two days, 48 hours near. And you can see here also some dynamics when boiler was stopping, reducing heat, and was fuel inside was drying, so it's dry it and burn it later. But mode inside the boiler is like fuel is dried. a lot of discussion on erosion and corrosion, and typically misleading discussions could have happen according to erosion and corrosion effect. Corrosion is gradual destruction of materials by chemical or electrochemical, like corrosion due to chloride or sulfur, and high temperature impact on tube material or ash covered tubes at high temperature. But mostly from the pictures, what I have ever seen was erosion effect. It is like where the material are removed from the solid surface by action of solid particles. So erosion would depend on particle size. When the fuel is not fully burned and the particle is big and goes through tubes, and flue gas velocity also. So if you have very good recirculation flow, which is hardly to controlling only pressure, as we can see from previous slides, and collision angle and surface hardness. So probably collision angle we cannot control, but particle size and flue gas velocity we can control through tubes. So in fact, most effects what I ever seen is erosion, and erosion is related to automation level. If automation level is something, so we have problems, and corrosion is it's happening, but not so often. Some, of course, distribution of how to say, from knowledge from the books about the erosion and corrosion, what could be the distribution between them, but in my life, erosion more popular effect instead of corrosion. Dew point, of course, we calculate dew point temperature from a flue gas, and we can monitor this. Forecast also, if we have load, especially for industrial, or not only industrial, but district heating applications, sometimes it's very good to know when the boiler would increase its capacity or reduce its capacity, and in advance, a little bit control in advance. And some parameters what we optimize is amount of fuel, primary air, pressure, and distribution. Secondary air usually is according to oxygen metering, but very important is the pressure, which affects hydrodynamic, furnace, grate rate, flue gas recirculation, and if you have fluidized bed, it would be also primary air and flue gas recirculation pressure to make a boiling layer stable, especially on fluctuating load. How we see the project's digitalization? Of course, we first take a data, collect, do analysis, collect online, install data collection software, run digital twin, do commissioning, and after that you will become a user of a digital twin. For the data collection and write software, we solved this issue according to IEC 62443 standard about the network and system security, industrial communication network, where if you have OPC firewall and we install data collection software on the level 3, we through the proxy send data to the level 5. It is on the cloud, and common backs on the separate path. These paths are absolutely different configured, and in the software level also, when from the cloud, SaaS cloud, we send data to level 3 data writing software, energy advice production, and we write data to OPC. From the OPC, it could be, for example, Profibus gateway to Modbus, or Profinet gateway, or Modbus, or whatever, or controllers. Return on investment, usually less than 1 year. We believe that the digitalization process should create value less than 1 year. If you have more expenses, or if a project is cost more, so something is in the strategy bad, something in digitalization strategy is bad. And these numbers, ROI, less than 1 year is very, very, very good controlled number. Some output, many data, but some of efficiency, economizer efficiency components, energies in megawatt hours, cost of electricity, etc. And you get reports like in monitoring system, but also advanced process control, the digital twin, because it's digital twin, it's not a monitoring system. And from the head of boiler house, it's of course connects to system periodically, gets report, track historical energy indexes, and analyzes results and plans technical maintenance. And for the technical manager, gets daily, weekly, monthly reports, evaluate quality of operation, make decision on technical maintenance issues. Of course, we are looking for partners because worldwide there are a lot of boilers, and our company is more or less cloud provider, but integration part of the projects, it's partners are important, and you can join to our global partnership. And how we see that you can achieve your goals and scale your services, develop your key accounts, and you can extend your clients' life cycle and help implement optimization strategies by yourself. Energy Advice is only a platform provider and algorithm provider, and it's easy to deploy. User-friendly and democratic interface is easy to deploy and does not require specialized and dedicated roles. Especially if you're automation guy, Fluids would be especially easy. If it's not automation guy, it is still easy to run code and collect data. Easy to maintain. We have libraries and templates which you can reuse, and algorithms are already pre-trained and optimized, so you can take and use it. And of course, you access knowledge because through the projects we day by day we get more and more different issues which we are solving. You would have trainings, you can deliver trainings to your clients, and of course all business create value and earn money, so it is profit sharing and specific and flexible pricing. Half an hour we spent coming back from advertisement to issues. 20 megawatt steam boiler, we install it. Why we install it? Why our client choose it as? Because we had bad KPI. We had bad KPI efficiency or production divided by fuel megawatt hour. And what we found numbers. It is historical data here on the top. Heat production decreasing, efficiency is decreasing. When we started digital twin, become everything on opposite. So it's from EA-SAS picture, where fuel savings near to 8% in 1 year through many dynamics and many its industrial application with steam consumption for the paper production. So you can imagine paper production is quite dynamic process. 30 megawatt steam boiler with 5 megawatt condensing economizer, thermal oil for gas consumer, and it's quite sophisticated project. It's quite, as you can see here, many components. and also silo stored in the silo. And for client, it was important to account the fuel and how you can see silo level and how we account in blue. We account and silo level in red. It, of course, a little form of coin. It's a little bit metering error, but finally tracking quite well. And here we are with a presentation. Thank you for your time. Have a nice day.